Hello everyone, I welcome you all in this presentation. In this presentation, we were discussing about the abrasive jet machining. So far in the previous video, we have discussed about the principle and the working, as well as we have also discussed about the different types of mechanism, material removal mechanism in the in the brittle and the ductile material. In this video, we are going to discuss about the kinetic energy, work done, and the material removal rate for the brittle and the ductile material. Okay, so let's start. Kinetic energy, here we are considering this kinetic energy for a single abrasive particles. That kinetic energy is generally given as half of m into v square. Now v is the velocity of the particle and m is the mass of this particle. So for that mass, we are just assuming that that is rho into volume. That rho is the density of this grit. Here we are considering that is abrasive particle, that is a grit we are calling it because it is very small in diameter. Okay, so that density of the grit into the volume of this grit. Okay, now we are considering this grit as a spherical in nature. Okay, so that spherical, that is of the diameter dg, so the volume will be 4 by 3 pi rg cube, but we have to convert it into the form of dg, so it will be like pi by 6 into dg cube. So this is the volume of this spherical grit. Okay, so this kinetic energy will be like in the form of mg and dg, so it will be like kg, that is half of mg into v square. So mg is equals to rho g into vg, and mg is equals to rho g into vg, that is pi by 6 dg cube. Okay, so when you will put it, you will get this pi by 12. This kinetic energy will be equals to pi by 12 rho g into dg cube into v square. Okay, so this is the kinetic energy. Next is the work done. Now when this particle, if this is a workpiece surface, and this is basically the portion, means it will collide over here, sorry, yeah. So when it will impinge over this surface, it will move inside. Okay, so this is basically the we are considering this is a indentation, means delta, means if whatever the abrasive particles which is at this exit area, it will collide over here. So when it will collide at this workpiece surface, it moves some inside. Okay, now that movement is basically the delta, that is indentation dropped by that particular particle. Okay, so that is if when they will when they will impinge over this workpiece surface, they moves inside. Okay, so they are coming in contact with this workpiece surface, means they are coming in, there is some area that is covered by this grit. Okay, that is area some covered by the grit. So whatever the strength or the hardness of that is of that abrasive particle have, it has which is when it is impinging over the surface, there is some area. So the force will be equals to area into the hardness of this abrasive particle. Okay, so that is the force, and that is distance that is traveled by this abrasive particle inside the workpiece. So this will be delta. So the work is given as F into delta. Now that is a work material, but that maximum work that can be covered like when it will become semi-spherical. Okay, so that is also what is the force and what is the distance travel. So that is again delta. But now this is not that is semi-sphere. Okay, that semi-sphere part is only covered inside this workpiece surface, so this work will be half. Okay, so this will be equals to, the work done will be equals to work done by the particle will be half of F into delta. Now F is equals to indentation area into hardness. Okay, so the indentation area will be equals to, if R is the radius of that, then that is pi into R square, hardness is H. Okay, so when I'm just putting this value, F value over here, and we'll get this value, that is W equals to 1 by 2 pi into R square into H into delta. Okay, next is when we were considering the modeling of MRR in the last video, we discussed that we have to take one assumption, that is a complete kinetic energy is utilized to remove the material. Now if you are remove, the meaning of this remove of the material here is the work done by this abrasive particle individually. Okay, so the kinetic energy of an individual particle is equals to pi by 12 rho g into dg v cube into v square, and the work done by a single particle, that is equals to this one. Okay, so if the complete energy is transferred, it means that the kinetic energy will be equals to the work done. So from this, kinetic energy will be equals to work done. So this will be like pi by 12 rho g into dg cube into v square equals to 1 by 2 pi into r square into h into delta. Okay, now this in the last video we have calculated this r value, that is root square dg into delta. Okay, so I'm just putting this r square value, so this will be equals to dg into delta. So when we'll put this value, we'll get this like over here I have put this value. Okay, so this will be delta square, and delta square will be equals to dg square into v square into rho g upon 6h. So I'm just finding out this value delta. So this delta will be equals to dg into v into rho g upon 6s raised to 1 by 2. Okay, so this is the value of delta, means the indentation value in terms of dg, velocity, rho g and h. Okay, why we have find out this value? Because I will tell you when we will calculate this MRR in next slide. Okay, so this is just a give. If there is a value of delta, then we can just replace that delta with the help of this values. Okay, different values, so that we can get a different formula. Okay, so next is the material removal rate for the brittle material. Okay, now the volume, the MRR, that is given as mm cube per second, means amount of the volume that is removed per unit time. Okay, now the volume is here we are considering the volume that we have calculated last time, that is VB, but for the time being, means for per unit time, we are taking that the material rate, that is the how much amount of the abrasive grids per unit time with respect to the mass of the grid. Okay, mass of the grid. Okay, so this is basically the rate of the grid, means abrasive particles, moving or impinging on the workpiece surface per unit time, or mass with respect to the mass of this abrasive grid, a single grid. Okay, so that will be equals to, sorry, so this will be equals to VB, that is a volume of the brittle material. In case of the brittle material, m dot g, that is grid per second. Okay, and the mg, so this is the meaning of m dot g upon mg will be the number of impacts by abrasive grids per second. Okay, so the meaning of it is number of impacts. Okay, so this will be the volume that we have already calculated in the last video, that is 2 by 3 pi into dg into delta raised to 3 by 2, and the mass of this, that is rho g into vg, that is a volume, and volume we calculated in terms of dg, that is rho g into pi by 6 into dg cube. So when you will put these value over here, so this will give you 2 by 3 into pi into dg into delta raised to 3 by 2 into m dot g as it is, and pi by 6 into rho g into dg cube. Okay, and when you will manipulate it, it will give you 4 m dot g upon rho g into delta upon dg raised to 3 by 2. Now we have to put if in some of the example, if value of the delta is given to you, then we can directly use this formula of the material removal rate in case of brittle material. But if delta is not given and value of the h v velocity is given to you, then we have what we have calculated in the last slide, we have to put over here. Okay, so when you will put this value of the delta, then it will be dg into v raised to into rho g upon 6h raised to 1 by 2. So whole power is 3 by 2. Okay, so here dg will be cancel out, and when you will manipulate it, this equation will give you 4 into m dot g upon rho g into v raised to 3 by 2 into 6 rho g upon 6 h raised to 3 by 4. Okay, so this 1 by 2 into 3 by 2, that will be 3 by 4. Okay, so there is a numerical values are like 4, and in the denominator it will be 3 raised to 6 raised to 3 by 4. So when you will calculate it, it will approximately, not sure, it will be approximately will be equals to 1. Okay, so the approx value of this MRR for the brittle material will be m dot g into v raised to 3 by 2 upon this is rho g, and this is rho g raised to 3 by 4, so it will be over here. So this is rho g raised to 1 by 4 and h raised to 3 by 4. Okay, so this is the material, this is the value of material removal rate in case of the brittle material. Hope I think the terminology is clear to you. Okay, so next is the material removal rate for the brittle ductile material. Okay, again same that we are using, that is volume in case of the ductile material as a workpiece, and the number of impacts by the abrasive grids. Okay, again the abrasive grids per second upon the mass of individual grids. Okay, so this will be equals to vd into m dot g upon mg. Okay, so the value that volume of this in case of the ductile material we calculated, that is pi into delta square into dg by 2 minus delta by 3, that that I told you in the last video. But the value of this delta by 3 is very less in comparison with the dg by 2, so the value that we are taking, that is pi into delta square into dg by 2, so this value. Okay, so the value of mg is same. So when you will put these values into this equation, so this is the value of mg, and when you will put this equation, this will give you this formula. So when you will manipulate it, it will be like 3 into delta square into m dot g upon rho g into dg square. Now again, in case of if the value of delta is given to you and the other values is given to you, then you can directly use this formula. But again, in case of h or velocity is given to you, then we have to manipulate it, so we have to change it accordingly. Okay, so when you will change it, it will give you that value of the delta. When you have to put it, that is dg square into v square, and this delta value was rho g raised upon 6h raised to 1 by 2. So this will be square, so this will be cancel out. Okay, so this is rho g by 6h. Okay, so this will be m dot g into rho g upon dg square. So when you will means when you will calculate it, it will be like material removal rate of the in the case of ductile material, it will be 1 by 2 into m dot g into v square upon h. Okay, so mg, that is abrasive grit per second. Okay, v, that is velocity, and h is the hardness. Okay, sorry. These are the references that I have taken for this video. Okay, and thank you so much, guys.